Hello everyone, today we will discuss about path. So before going to this topic path, we will know about walk and trail. So what is a walk? Walk is a sequence of vertices and edges, and it is also simply called sequence of vertices, and these sequence are finite sequence. So walk is a finite sequence of vertices and edges. So come to the definition of walk. So a walk in graph G is a finite sequence. So W is a walk and this is the finite sequence of vertices and edges. The vertices are V0, V1, V2 up to Vk, and the edges are E1, E2 up to Ek. So this is walk is V0, E1, V1, E2, V2 and this way, which terms are alternately vertices and edges such that for I less than 1 less than I less than equal to k, the edge EI has end Vi minus 1 and Vi. So here E1 is an edge and the end vertices E1 has two ends, that is V0 and V1, and E2 is an edge, so E2 has two ends V1 and V2. So each edge EI is immediately preceded and succeeded by two vertices with which it is incident. And the integer k, that means k, the integer k, that is the number of edges in the walk, is called the length of W. That is here k number of 40 edges, so k is the length of the walk. And here V0 is the starting vertex and it is also called origin of the walk, and Vk is the end vertex and it is called terminal of the vertex. So V0 is the origin of the walk and Vk is the terminal vertex or terminus of the walk, and all the rest of the all vertices, that is V1, V2 up to Vk minus 1, are the internal vertices. These are the internal vertices, and here W has length k. And it is also written as W equal to V0, V1, V2 up to Vk. This is the finite sequence of vertices. Next come to this graph. So there are 5 vertices and 10 edges, and we'll take one edge, that is W1. So first of all we write one vertex, that is V1 is here the starting vertex of W1. So V1, E1, V2, E5, V3, E10, V3, E8, V4. Now we'll take here W1 is a walk, and this V1, E1, this is V1 vertex, starting vertex is V1 and end vertex is V4, and V2, V3 and V3 also are the internal vertices. So there may be repeated of vertices and edges. So in a walk there are number of vertices are repeated and number of edges are repeated. So taking another example of walk, that is W2. Next V1, E1, V2, E2, V1, E9, V3, E8, E8, V4. So this is another example of V4. So V1 and V1 is repeated here. E1, E2, E9, E8. So number of edges here, E1, E2, 2, 3, 4. So length of W2 is 4 because there are 4 edges, and length of W1 is 1, 2, 3, 4. So length of W1 also 4. Now come to trivial work. So what is trivial work? Trivial work has no edges. So that means it has length 0. So for example, for any vertex P of G, W equal to P gives a trivial work. So it contains only one vertex. Okay. Next come to open work or closed work. Before going to this open work and closed work, and we will know about the graph form. So the general graph form is if W equal to V0, E1, V1, E2, Vk minus 1, Ek, Vk. It is called V0 to Vk work. Okay, V0 to Vk work. So if V0 equal to V0 means starting vertex, origin and terminal vertex are same, then it is called a closed work. If the starting vertex and end vertex are different, then it is called a open work. So the definition of open work or closed work, given two vertices U and V of a graph G, and A U to V work is called closed, then it is U equal to V. If it is open, then U not equal to V. So taking example of closed work and open work from this graph. Taking W1 is a work. The W1 is equal to V1, E1, V2, E5, V3, E9, V1. And W2 is equal to V1, E1, V2, E5, V3, E8, V4. This. So W is a work and W1 is a work and W2 is a work. So see this, W1 is starting from V1 and end with V1. So starting vertex are same with the end vertex. So W1 is a closed work. And it is simply written as W1 equal to V1, V2, V3, V1. Sequence of vertices. And W2 is starting with V1 and end with V4. And so this is called open work, because starting vertex and end vertex are different. Started with V1 and ended with V4. Next we will discuss trail. So what is trail? If the edges are not repeated in a work, then this work is called a trail. So the definition is, if the edges E1, E2, Ek of the work W is equal to V0, E1, V1, E2 up to Vk are distinct, then W is called a trail. So a trail is a work in which no edge is repeated. So for example, come to this graph. W1 is equal to V1, E1, V2, E5, V3, E10, V3, E7, V5. And W2 is equal to Phi1 E1 Phi2 E2 Phi1 E1 V2 E4 V4. So these are two WACs. So in W1 WAC, V1, E1, V2, E5, V3, E10, V3, E7, V5. See, there are no edges are repeated. All the edges are different. But in W2, V1, E1, V2, E2, V1, E1, V2, E4, V4. So here E1 is repeated. So W1 is a trail. But W2 is not a trail. So every trail is a WAC, but every WAC is not a trail. Next come to path. So path, if the vertices V0, V1 up to Vk of the WAC W equal to V0, E1, V1, E2, V2 up to Vk are distinct, then W is a path. That means the vertex are not repeated. So any two paths with same number of vertices are called isomorphic paths. That means, for example, W is equal to V1, E1, V2, E5, V3. So here the vertices are not repeated. So W is a path, and we will take another WAC, that is W1. W1 is V5, E7, V3, E8, V4. So W1 is a WAC and the vertices are not repeated, and it is also called a path. So this has 3 number of vertices, and here also 3 number of vertices. So these two paths are isomorphic path. So same number of vertices are two paths having same number of vertices are called isomorphic paths. Next, a path with n vertices is denoted by Pn. So this W1 has 3 number of vertices, so it is Phi3. So there are 2 edges. So Pn has n minus 1 edges. So Pn has length n minus 1. So from this we conclude that path there is no repetition of vertices. So from this it is clear that there is no repetition of edges. So every path is a trail, but every trail is not a path. And from this example we also clear that every path is a WAC, but every WAC is not a path.